When a motor leaks electricity, it is easy to cause fire or electric shock. So how can we avoid accidents? How can we measure the insulation performance of equipment? Today, let's learn how to use an insulation resistance tester. Before using the insulation resistance tester, we need to make the following. First, we need to check if the insulation resistance tester works normally. We need to do an open circuit check and short circuit check. First, we do an external inspection. Place the instrument flat. First, check if the two probes are connected correctly. The black probe is connected to the 1 terminal, and the red probe is connected to the L terminal. Check if the pointer is near the middle of the scale. Now the pointer is in the middle. The appearance is normal. Second, we perform an open circuit check. Place the instrument flat. Separate the red line at the line end and the black wire of the ground terminal apart. Don't cross or intertwine them. Slowly increase the speed of shake. Shake the handle. It's to prevent short circuits inside the generator and damage the instrument. The speed reaches 120 revolutions per minute. The pointer stabilizes for 1 minute. The pointer turns in the direction of infinity. The open circuit check is qualified. Then slowly stop shaking the handle until it stops. It is to discharge through the coil and damping of the circuit. Third, we will conduct a short circuit check. Place the instrument flat. Short circuit the red line of the line end with the black line. Shake the handle 1/2 to 3/4 of a revolutions, and found that the pointer turned towards 0 and stopped rotating. Short circuit test is qualified. Fourth, the 3 checks are qualified. The megometer is good. After checking the instrument, we start to measure the insulation resistance of the motor. Motor insulation relative to ground and relative to phase. We first includes phase 2 ground insulation resistance and phase 2 phase insulation resistance and ground power off tag and repair discharge by connecting one end of the conductor to the shell and the other end is connected to the motor coil. Bring out UE and V. Third, power on test. Check if the motor is electrified. Open the junction box. Disassemble the connecting sheet inside the junction box. Measure the resistance between phase and ground 3 times. A to the motor's metal shell. B to the motor's metal shell. C to the motor metal shell. We measure the full resistance of AI phase megometer to ground. When measuring, the black probe is clamped to the part of the motor shell where there is no insulation, and the red probe to the AFA is to measure the insulation resistance, and found the pointer turning towards infinity, and then accelerated too. After reaching a speed of 120 revolutions per minute, rate the value, and found that the pointer was turning more than 500, indicating that the insulation of the EHAS winding to ground is good. Slowly stop. Now we will measure the full resistance of B phase megometer 2D. When measuring, the black probe is clamped to the part of the motor shell where there is no insulation. The red probe is clamped to the B phase megometer. Turn the handle gently and the pointer turns to infinity. Starts to accelerate. After reaching a speed of 120 revolutions per minute, and found that the pointer turns to more than 500 megaohms, indicating that the insulation of the B phase winding to ground is good. Slowly stop. Now we will measure the insulation resistance of C phase megometer to ground. When measuring, the black probe is clamped to the part of the motor shell where there is no insulation, and the red probe to the C phase megometer. Turn the handle gently. The pointer turns to the infinite direction. Starts to accelerate. After reaching a speed of 120 rotations per minute, and found the pointer turning to more than 500 megohms, indicating that the C phase winding has good insulation. Slowly stop. The measurement of insulation resistance of phase 2 ground is completed. Second, now we measure the insulation resistance between phase measure. The insulation resistance of phase insulation resistance 3 times A and B, A and C, and B and C. We use the AFA's megometer to the B phase rotor. When measuring, the red and black probes are not distinguished. The black probe is clamped to the A group, and the black probe to the B direction shaking group. Turn the handle, and find the pointer turning towards infinity. Starts to accelerate. After reaching a speed of 120 revolutions per minute, we found that the pointer was turning to more than 500 revolutions, indicating that A and B have good insulation. Slowly stop. Now we will measure the full resistance of A phase winding to the C phase winding. When measuring, the red and black probes are not distinguished. The black probe is clamped to a phase winding, and the red probe to C phase winding. Turn the handle, and find the pointer turning towards infinity. Starts to accelerate. After reaching a speed of 120 revolutions per minute, we found that the pointer was turning to more than 500, indicating that A and C have good insulation. Slowly stop. Now we measure the full resistance of B phase megometer to C phase megometer. When measuring, the red and black probes are not distinguished. The red probe is clamped to B phase winding, and the black probe to the C group. After turning the handle, the pointer turns to infinity. Starts to accelerate. After reaching a speed of 120 revolutions per minute, we find the pointer turning to more than 500 MHz, indicating that the insulation between B and C is good. Slowly stop. The insulation resistance between phases is measured. We know the voltage of the motor cable. Next we calculate its qualified insulation resistance. First, measure the insulation resistance. After match electrical equipment installed newly or repair. Lower. The insulation resistance must not be less than 5 megosecond. According to the known voltage of the line and electrical equipment, we can calculate its qualified insulation resistance. Next we will learn the calculation of different types of insulation resistance in different environment. First, in general, normal environment, the insulation resistance per volt of working voltage should not be less than 1000 ohms. For example, the working voltage of a motor is 380 volts. The insulation resistance should not be less than 0.38 megohms. The formula is insulation resistance greater than or equal to 380 volts times 1000 ohm divided by 1 mega, 0.38 megohm. or 380除以1000等于0.38 megohms. The voltage of household appliances, such as washing machines, air conditioners, is 220 volts. Its insulation resistance should not be less than 0.22 megohms per volt. 220 volts multiplied by divided each volt by 1 megohm equals 0.22 megohm. In a humid environment, calculate based on not less than 500 ohms per volt. For example, a 380 volt line, the insulation resistance in normal environment should not be lower than 0.38 megohms. But in a humid environment, it should not be less than 0.19 mega. The insulation resistance greater than or equal to 380 volt times 500 ohms divided by 1 mega equals 0.19 mega. Third class 1 portable electric tools, hand drills, hand grinders, construction site equipment, floor fans, etc. The insulation resistance should not be less than 2 megohms. Fourth, 4. Class 2 power tools, which are double insulated. The insulation resistance should not be less than 7 mega. Fifth, for high voltage above 1000 volts lines and equipment, the insulation should generally be not less than 1000 megohms. 6. The insulation resistance of insulator should be not less than 300 megohms. We have measured the insulation resistance before. During the experiment, we need to pay attention to the following points. Firstly, before measurement, turn off, power off for verification of live part, and hung up before measurement. Second, when measuring the insulation resistance of motor windings to ground, L connects to winding and E to motor shell. Third, the pointer of the megometer before use can stop at any position without affecting the final measurement result. Fourth, the unit of megometer is megafifth. The greater the insulation resistance value, the better the insulation performance is. In this class we learned the measurement of AC voltage and precautions. That's all for this lesson. Thank you for watching. After class, please think about the following question. Decide which picture has the correct measurement method.